In the bioengineering department, and today I'm going to talk to you about the molecular and cellular hallmarks of cancer. So, I'm not going to sit here and bore you with statistics of cancer and how many people die or people are affected each year and the general trend over the past decade or so. I'm just going to give you a basic understanding of the molecular mechanisms that govern cancer in the cell. So, the normal cell, this image doesn't do it the justice that it deserves because it's much more complicated than that. It's governed by principles that control when and if it should divide, from external and internal. So if they grow when they're stimulated, when they're damaged, they shut off everything so that they don't reproduce. They only divide a limited number of times, and if the cell is damaged beyond repair, it will do a programmed cell death called apoptosis. So, in 2000, there was a wonderful paper by Robert Weinberg and Douglas Hanahan called The Hallmarks of Cancer. They simplified all the complexity behind cancer into 6 major hallmarks that broadly cover what each cancer is. So, as stated, the paper makes the claim that all cancers have 6 major hallmarks that transform them from a normal cell to a cancer cell. So, the first one, self-sufficiency in growth signals. The cell uses receptors to communicate with the outside. If these receptors are bad, it can't communicate. In cancer, they have mutated receptors or they overgrow these receptors, and in turn, they are constantly getting false information from the outside. It's making them grow and divide when they're not supposed to. Another example in cancer is sometimes they produce their own growth factors, so they're constantly stimulating their own growth. The second hallmark is insensitivity to anti-growth signals. So as you can see in this one, there's a signal molecule, the receptor binds it, it sends the pathway down to the nucleus and tells the cell what to do. This is basically the basic communication of the cell. In cancer cells, they bypass this. So even though there's a bunch of molecules to signal to stop growing, there's either a mutation here or something down in the nucleus that's preventing this cancer cell from realizing what it should be doing, and it just continues to divide and grow. The third hallmark is evading apoptosis. So apoptosis is programmed cell death. Basically, the cell commits suicide. It does it. A normal cell does this when it realizes that the damage that has been done to it is too much to repair. So it's not going to divide, because if it divided with that damage, then it would just pass it off to its offspring, the 2 cells it divides to. A cancer cell, however, bypasses this. It will divide no matter what. If there's mutations, if there's problems, if it made a mistake in the DNA replication, if it has the wrong proteins, etc. It undergoes a series of reactions to degrade its internal infrastructure and vital components, and a cancer cell will not do this, so it will continue to grow. And the fourth one is limitless reproductive potential. So a normal cell is limited by the number of times it can divide. They have these protection caps at the end of their chromosome called telomeres. They're like I don't know what those are in your shoelaces, but they protect the end of your shoelaces. That's what they do for the chromosomes. A normal cell will divide. Every time it divides, it loses some DNA, but that's junk DNA at the end. After a certain number of divisions, which they call the Hayflick limit, the cell cannot divide any further because it lost a lot of DNA and it's getting to crucial DNA. Cancer cells bypass this. How do they bypass this? They use this enzyme called telomerase that extends the telomere. And in normal cells, this enzyme is shut off. In cancer cells, this enzyme is upregulated or expressed. And as you can see in this image right here, when a cell divides, a normal cell will be losing its telomere. A cancer cell is constantly maintaining it, giving it unlimited amount of divisions. Therefore, it's immortalized. The fifth one is sustained angiogenesis. Angiogenesis is basically the ability to recruit blood vessels and nutrients from the body to the cells. And normal cells don't have this ability, at least when you're early on in development they have this ability, but later on in life they do not have this ability. However, cancer cells do. They produce their own angiogenic factors, they recruit blood vessels to them, and they're constantly getting supply of blood and nutrients. And that allows them to grow. And the final one is tissue invasion and metastasis. So cancer cells obviously spread to the body. Normal cells cannot do this. And the cancer cells break away from the organ site and spread throughout the body. And usually it's one pioneer cell that does it. But usually schematics can show you this is the blood and it spreads throughout the body. Normal cells don't have this ability. So again, those are the 6 hallmarks of cancer. And actually, in 2010, they introduced 3 more, but that's a different topic. All right, any questions?
That was generally really good. My only question would be, from that pioneer study you talked about at the very end, is that why some women, like say with the BRCA1 or BRCA2 gene, might have the breast removed like Angelina Jolie did to get rid of breast cancer risk, but then might have ovarian cancer a few years later?
Exactly. So in clinical studies, they have a relation between if you have breast cancer, what you're most likely to have as your second one, depending on where the pioneer cell goes. So they have these relationships down, but in the end, all I can say is that if it starts in one, if the tumor starts in one place, it can move to another part of the body. Any other questions?
All right, let's thank the speaker.
Thank you.